Okay, so I'm sitting here sweating in room 305 to bring you part two of the January 24 regions, and the last one in the book. All right, so this one says factor completely. The first one, we've done several of these, right? So we're going to group this side around this side and this side, right? We're going to take a common factor of the both of those. So we could take out an x squared, and we're left with x plus 4, the minus sign. And we're going to take out the common factor on the right side is 9. So we're left with x plus negative 36 divided by negative 9 is 4. Okay, so these two are common factors. So we could factor these out, and we're left with a factor of x squared minus 9, and then we could factor that one again to x minus 3, x plus 3. Okay, so that's 25. 26, determine if x plus 4 is a factor of 2x cubed plus 10x squared plus 4x minus 6. Okay, explain your answer. Well, if this is equal to 0, then we know we have one of the roots, right? So if we use the 0 rule, we're going to test x equal to negative 4. Right, so we're going to plug this in. 0 is equal to 2 times negative 4 cubed plus 10 times negative 4 squared plus 4x minus 16. Okay, now you put it right in your calculator the way you see it. So I'm going to do that on my calculator, just so everybody knows. Right, 2 open parentheses, negative 4, close parentheses, raised to the third power, right? And I got to go over, plus 10, negative 4, raised to the second power. Right, go over, and then we have plus 4 times negative 4 in parentheses minus 16. And that gives us 0, right? So we could say that 0 is equal to 0, since negative 4 is a root, x plus 4 has to be a factor. Okay, the other way to do it is to use synthetic division, right? You could use, not synthetic division, long division, and divide it and see if you get no remainder, right? But this way is a little shorter. And use the calculator, right? Write it out. Substitutions always go in parentheses, and make sure that you put it in exactly the way you see it. All right, an investment of $1,000 reaches a value of VT. According to the model, VT is equal to 100 times 1.01 raised to the 4t. Determine the average rate of change. Okay, so we need a t and a v, right? Really, this is, if you want to think about it, this is y, and we can call t x, right? So we could think of that, and we could do change in y over the change in x. So we're going to figure out v of 2 first. V of 2 is 1,000 times 1.01 times 4 raised to the second power, which is equal to, again, you put it in the calculator just the way you see it, 1,082.86. Okay, it says to the nearest dollar, so I'm just going to keep 2 extra decimal places. V7 is equal to 1,000, 1.01, 4 times 7, and you put that in, you get 1321.29. Okay, so now we have the points. If you think of them as x and y's, right, the input of 2 gave us an output of 1082.86, right? And the second one is an input of 7, gives us an output of 1321.29. All right, so now I could do, y2 minus y1 over x2 minus x1. That's my average rate of change. So I have 1,321.29 minus 1,082.86, all divided by 7 minus 2. Okay, so this becomes 2, if you subtract this, 238.43 over 5, and we get a change of $48. All right. Like I says, if you have to, stop the video and copy this down. The next one, 1 over the cubed root of y squared, right? Times at y to the 4th. So first of all, let's multiply the numerator. So we have y to the 4th. And let's do the denominator as a fraction, right? So we do y to the 2 over 3 power, okay? And then when we divide, we're actually subtracting. So you take this minus 2/3, right? And I'm lazy, so I go to my calculator and I say 4 minus alpha y equals 1, and I put in 2/3 and I hit enter, and I get 3 1/3. You could leave it like that, or you can do it to a mixed number. You go math. I don't even know how to do it on this one. Cancel, right? But that's 10 thirds, right? So we go back here and we write is equal to 10 thirds. Right now, it's important. It says, what is the value of n? So you can't just leave it like that as 10 thirds. You'll get a point taken off. So we have to write n's equal to 10 thirds. And that's your work shown above is your justification. And make sure you answer the question what it's asking. What is the value of n? Well, n's equal to 10 thirds. All right, so I did a little research on this normal distribution stuff, and it was really simple on the calculator. So I want to do this one, and I want to go back and do another one from the very first test in the green book. So let's look at this. So very simply, your calculator, an TI-84 plus, or a TI-83 even, your calculator, what you want to do is you want to hit the second button. You want to hit the vars button, because above that is this little thing, DISTR, which means distribution. And you can work from the distribution, right? And then if you see, we want the number 2. Number 2 will give us your normal CDF, right? So we want the normal curve. A couple other things. Now, in this one, this little fancy U here is the mean. And the standard deviation is the same symbol, standard deviation. Okay, so this one tells us, let's highlight a few things, right? It tells us that the heights of the members of the ski club are normally distributed, so that's why we can use normal CDF, okay? The average height, this is the mean, is 64.7, and the deviation is 4.3. Determine the percentage of the club members between 67 and 72. So to do that, and this will pop out a percentage for you, which is really cool. All right, let's look at this now. So our mean is equal to 64.7. Our standard deviation is equal to 4.3. Whoop, no. Yeah, 4.3. Our upper is 67, and our lower is 4.3. So let's go to the calculator and see. Yours is the same buttons as the one I have here. All right, so I said the first thing you do is you're gonna go, I'm gonna clear all this off, right? So we only have this on the screen. We're gonna go second, right? Second vars. And yours will come up, it'll look different, but one is normal PDF. The second one is normal CDF. This is what we want. And you can see the lower bound, the upper bound. You have to input the lower bound, the upper bound, the mean, and the standard deviation. So you go here. Yours is a little different. It comes up in a screen that's different, and it's up and down. But eventually, when you put these numbers in, you'll hit enter, and you'll go to the main screen, and then you'll have to hit it again. So this one here, the normal CDF, the lower bound is 67, right? I have to put in a comma. See, yours you won't have to put in a comma. 72, comma, right? The mean is 64.7, comma, and the standard deviation is 4.3. Okay, so you go through, you put those in. I think the last thing is paste, which means it's going to paste it to this screen here, and you just hit enter, and we get 2.25158. So between those two bounds, that means 25.158% of the data is between those 2 points. Okay, so very simply, we wrote all this down, and now we can just say 25% of the members are between 67 and 72 inches. Okay, so that's that one. So I want to go back to page 6. So everybody turn back to page 6 in your green books, and we're going to look at number 30. Okay, and I'm going to get it, and you're going to go look for it. And here we are, page, that was the first Regents we did. It was the very first one. Where are you? August. Oh, we're looking for number 30. Let's go the other way, Tom. Oh, wrong Regents. I think it was August. Oh yeah, because I looked at it before. August. Page 6. Page 6 is August 22. August 22, right? Oh, that's January 23. What's wrong with me? August 22. This is August 22. August 22. All right, here we go. Number 30. All right, so let's look at this. So we have a study done at the hospital, has an average weight of the baby's 30.39 kilograms, and a standard deviation of 0.55. So we can put in the 33 for the mean, 3.39 for the mean, and 0.55 for the standard deviation, right? Let's write that down. So our mean is 3.39, right? Our standard deviation is 0.55. Okay, all the newborns in this hospital closely follow a normal distribution, which means we can use that algorithm in the calculator. Last year, 9,256 babies were born in the hospital. Determine to the nearest integer approximately how many babies weighed 4 kilograms, more than 4 kilograms. All right, so our lower limit is going to be equal to 4 kilograms. And our upper one, we can make something even ridiculous and we'll get the number, right? Just to make sure that we cover everything. The upper would be equal to, let's say, 200 kilograms, right? There's no way there's going to be a 200-pound kilogram baby. So we can do that. So let's go to the calculator and let's put those in, right? Remember, yours is going to come up on the table. Once you hit, let me try my other calculator. Maybe that'll be more simulated to yours. Let's try this one. So we're going to go second VARS, right? We want normal CDF, number 2. Mine does the same thing. So yours may be lower, upper, mean, standard deviation, and then paste. Mine, I just have to put them in as I go along. So the lower is 4, comma. The upper, I said to put in 200, right? Something ridiculously, so we know we include all the data, right? Our standard deviation, our mean is 3.39, comma, and our standard deviation is 0.55. Right, I'm gonna go outside here and I'm gonna hit enter. And you can see that we have 0.13369, right? So that means approximately 13% of the babies born at that hospital are above 4 kilograms, right? So let's write that down, right? So we're going to go back here and we're going to say the percentage is 0.13369%. So that's the percent of the babies born above. And how many babies were there altogether, right? We have 9,256. So we have to multiply those two numbers. And when we multiply those two numbers, we get times 9,256 is 1,237.48. So we could say 1,237 babies goes to the nearest baby, right? Rounded to the nearest integer. Babies were born, weighed more than 4 kilograms. Okay. All right, let's go back to what we're doing. Maybe we'll do one more just to cut this short. Let's go back to 30 is another one that we didn't really look. I don't know how long we've been going, but let's do one more. Let's go back to this one, right? Number 30. So the formula, an explicit formula means we could just plug a number in for n, and we can get the output for that. So in this one, A0 is equal to 6 plus 6 times 0, which is 6, right? A1 is 6 plus 6 times 1, which is equal to 12. A2 is equal to 6 plus 6 times 2, which is 18. we could see the pattern already. The third one is 6 plus 6 times 3 is equal to 24. Okay, so the difference, it's in an arithmetic series, but every one of these go up by plus 6, right? So that's the rule, plus 6. So for a recursive formula, you have to depend on the one before. So the first thing you have to do is you have to give a starting point. The first one is 12. A1 is 12, right? And then AN is equal to the one before. And how do we represent the one before? Well, if we're talking about the third one, we need the second one. So that means we need N minus 1, the subscript N minus 1, and the rule is plus 6. Okay? More of a ninth grade question, but let's stop right here for this video, and I'll post another one tonight. Okay? Bye.